Hey YouTube family, welcome back to the session 8 of Java Full Stack Made Easy. In the previous session, we discussed about if else. Now we will be discussing about the switch case. So let me just put this into an example. Like what I mean is that let's put it into the coding part and understand what exactly is switch case and how switch case works. So when you have multiple conditions to be checked on integral constants, use switch case. Switch case is faster comparing to if else. Let me give you a very simple example for the same. If suppose I have something like int, and what I want to do is I want to check if something like, let's say instead of int, let's say I have a char vowel, and there's a vowel entered by the user, that is a, and I encourage you to read this, try read the character from scanner. Okay, try to do that as an example. So I'm writing it directly. In the previous session itself, I spoke about the scanner class se.next, right? So for we had next int, next double, next float. Likewise, I encourage you to check for what is the method to read only a single character using scanner. Can be at times bit tricky, but let's hope you will find out the way of reading one single character using scanner. Okay, now I have a vowel char, vowel a. It can be anything. Okay, now what I want to do is I want to check whether the entered character is vowel or not. So I will put a condition. If the entered character, let's call it as ch, if ch equal to a, or maybe e I o u. Okay, so if any one of this is given, then it is a vowel, else it is not, right? So and you, so either this way I can check it, I can compare it and say system.out.println, it's a vowel, else system.out.println, not a vowel. So very simple example I'm taking. Let's save it and run this and check. So it says it's a vowel because it what I have entered is a. Suppose if I enter any character which is not a vowel, W, I'll save it and run it. So here we go. It says it's not a vowel, right? So now either I can design it this way, or there are various other ways. I can write multiple switch, right? If character equals to a, else if equal to e, else if. Likewise, I can have else if as well, right? So this is just to make you understand the concept of switch case and everything. Okay, there are always better ways of making use of the things. Okay, ch equal to a, then system.out.println and do something, else if do something, else if do something, right? So what I can do is if I go with this, and then I can just print it's a vowel, and then ch equals to. So here I'll say it's a vowel, and plus if I just write ch, then it will also print me what vowel is entered. So else if, likewise I can go ahead and keep writing the else if ch equal to e, system.out.println, that is also a vowel, and which vowel is entered. Similarly, I can go for the other conditions, a, e, then let's go for I, o, and u. Okay, in the last else case, not a vowel. So these are the two ways using if else. I'm using this. So let's save it and run this piece of code and understand how things work. So it says it's not a vowel because what I have written here is W. So let's go ahead and write O, save it, run it, and check what is it. So now O is a vowel, it's a vowel O. So this way we can do it, right? So instead of doing this, it is better to make use of a switch case. Let me first create another repository for the same, and let's work on that. So this will be our day 8 demo 1. Okay, I'll add this. This is just a problem statement. You can consider what would be the better way of doing it. So instead of doing all this, I can make use of a switch case instead of going for if else. What I can do is I can use a switch and switch to what? Switch to the character. Okay, and based on that, we can just write the cases. So while writing switch cases, we should ensure that cases cannot be duplicated. Okay, switch in case of a, what needs to be done has to be written here, system.out.println. If it is vowel a, then just print the statement as vowel plus the character. Okay, so similarly for other cases also I can write switch case e, I, o and u. Like we have else, we can write a default case. What should happen if it's not in the above provided case? Okay, so in the else case, not a vowel. Okay, so that way we should be able to achieve whatever we have achieved in the previous example itself, but this is fast. And also you can notice that when I cannot duplicate the case, you can see that it is a duplicate case. Case a is written, so we cannot duplicate a case. Okay, so this is how the syntax of switch case works. Default, that's it. Let's run this and check. And now my character is O, right? So O is the vowel. I'm expecting it to print me O is a vowel, and that's it, right? But when I run this, you notice that what is being executed. When I run it, it says vowel O, again it says vowel O, and then O is not a vowel O. That means it is executing this statement, and it is executing this system.println, also this one. If this vowel that I enter is A, you will notice that it is going to print me A here, and then again not a vowel. Okay, to understand it better, I can say vowel A instead of this CH, vowel E, so that we just get the difference between the statements and understand the flow is continued. Okay, U and default, not a vowel. So when I run this, you notice that it says vowel A, E, I, O, U, and not a vowel A. Everything is being printed. Now why is that? That is because of two reasons. One is that first thing is switch understands that there are no duplicate cases, and switch works only with the constants. Okay, switch works with integral constants. Okay, so only integer values are allowed here, int values. So now int in the sense numeric values will be allowed. Like you don't be confused whether byte, short, int and long will be allowed or not. So switch works with the integer values. So here I am giving all the values as character, because character can automatically be converted into integer. That is why it is possible here. Okay, so now we know that cases cannot be duplicated, right? So cases cannot be duplicated. What switch is doing is, since it is working on a constant, there is no expression to be evaluated. So a constant A, when it is evaluated, so switch understands that there is no duplicate case. So I have to continue the flow. I don't need to check all the other cases. So it is not checking the other cases. Because it is not checking the other cases, it is executing everything that is written here. Okay, so how do we correct this? So what we have to do is, we have to put a break statement after every case, so that it comes out of the switch block. Okay, so I have to keep adding the break statements. So writing a break statement syntax wise is not compulsory. It is completely allowed to write a switch without a break statement, but what it does is it continues the flow of switch and keeps executing everything. So this can be one of your OCGP exam question. Okay, so let's save this, but syntax wise break is not necessary. If not given, all the other things, wherever the switch becomes true, rest all things will be executed. So let's save it and run it now. After adding a break statement, it works perfectly fine. Vowel A comes here, breaks the flow, comes out of switch block. Okay, that's how it works. Now the second point, as I told you, it works with the integral constants. Like why is it working with the char? That is because suppose if I do something like system.out.println here, and if I have an integer variable int x is equal to, if I do a ch, at that time it is fine, I don't need any explicit typecasting. Ch can easily be converted into an integer value. Ch as of now it is a, so it will be converted into 65. This is something we have seen before itself, right? So that is why this ch is automatically converted into a integral value, and this a is now considered as what it is. The ASCII value of it is compared and it is being tested. So that's why everything it's happening internally. That's why we don't need to worry about it. But if you look at the syntax of switch block, so when I say a switch expression, at that time you notice that cannot be resolved to a variable, and when I try to put a control space here and try to give something different, maybe I give some other value 99.5, so at that time it gives me an error saying that cannot switch on a value of type double, only convertible int values, strings or enum variables are permitted. Okay, for switch you can see that it's asking us to give any one of this, right? So int values is what I said. That is because before Java 1.8, strings were not allowed in switch, only integers were allowed in switch. So hope that is clear to you. I'll remove this, and also what we can do is I can show you the same example. We can go back to the previous versions and check whether string values are allowed or not. So first let me just put this a valid switch expression and how the syntax of switch looks like. So let me add another file, a demo to, let's call it a switch. So because a switch is working with the constants, that's why it is faster. And the one important point with the switch is that it cannot work with an expression. Like for example, if I am writing something like switch to int x and check if x is greater than 10, we cannot do this. Expressions will not be valid here. You cannot write it like that. Case constants of type boolean is incompatible with switch selector type int. So which means that you cannot write expressions. You cannot write a case where you write the case like x is greater than 10. What type of case you can write? You can write a case 10. This is fine. Constant. A constant is allowed here, but expressions are not allowed in a switch case. Do remember that part. Expressions cannot be evaluated into switch. Only integral and string constants are allowed. String constants are allowed after 1.8, and in cases only the constants have to be checked. That's why switch is faster. Okay, hope that is clear to you. Now I'll go back to what I was writing before. What I'll do is, instead of making this as char, I'll make it string. Okay, string ch. Obviously when I make it string I have to do it this way, and even the comparison, and it will not be converted into int automatically, so it's fine. Ch directly can be written because it is a string, it is fine. Now I have to compare it this way. Okay, so I'm working with a string now, string constants. This is also fine, and but this is allowed only after Java 1.8. hopefully 1.7 or something it was introduced. Let's see now how things will work. So let me just save it, and if I run it will be the same itself, right? So how do I compile the same piece of code to the previous version? Although I don't have any previous version of Java installed in my machine, so I'll copy everything that's written here. Okay, and then what I'll do is I'll go to my notepad. Okay, and sorry, let's just save it as a new file here. So this is my Java file. So what I'll do is, anyways, let's open a new notepad. New tab. Let's paste whatever code we have written there, and let's save it as demo1 because the class is declared as public. It has to be in this file name itself. So let's call this as switch example. Okay, so now the file should be saved as switch example. Copy, let's save it, paste it here. Let's go to maybe desktop or something. Let's save it there. Yeah, switch example. Let's write it as .java. So it will be a .java file which I'm saving. Let's save it, and we'll go with the traditional approach of running the Java applications. So let me open the command. Okay, and now I'll switch myself to the desktop. Let's do a Java C and see switch example will work or not. So when I try and do this, Java C obviously is used to compile the Java program, and the Java switch example should be used to run the Java program. So it is running it completely fine. Now let's just check the path, because in my system the path for the Java is set. That's why it is fine. So you can see Oracle Java path is given. So what I will do now is the same thing. If the path is not set, if you are saying a error like Java C is not recognized as an internal or external command, at that time what you have to do is you have to use this statement, set path equals to C:/program files /java/jdk/bin. So this is what you have to do. After that you will be able to compile and run your Java programs. Now what I will do is, while compiling this Java program, Java C ---- source I will use. I'll go for 1.5, and then I will use the switch .java. So now what will happen is it will compile with the Java 1.5 version. So when I use 1.5 version, it says warning, bootstrap class class path not set in conjunction with source 5. Source option 5 is no longer supported. Use 8 or later is what it says. That's because of Java 21 is something that I'm using. So it is asking me to make use of Java 8 or later. If you go back to the previous versions, that is 1.5, 6, 7, 8, so the switch with string constants was not allowed. We can, as in 21 version, we cannot go back to that. So let's at least go to 1.7 and see. It is asking us to go to 1.8, but it's still an error. I cannot go. I have to go till 8. If I go to Java 8, then obviously it is a valid statement itself there. So I'll close this, and let's see it here. Switch with string in Java, right, was introduced in, so we are giving a question mark. So use string in switch case Java Stack Overflow. Let's ask this to Google, because that there we will get an AI result there, right? So switch in Java was introduced in which version? Switch, not just switch, switch with string in Java. You can see that use of switch string type in Java, switch statement was introduced into Java 7. So before that it was an error. So we used to use only switch with the integral constants, right? So hopefully it's clear to you. Now we can work with the string constants, but before this we used to work with only the integral constant. And I hope the concept about switch is clear to you, how to make use of switch, the syntax about switch, the default case. And one more important point about the default case is that I can write the default case anywhere. Like I can start it with the default case, write a break statement here. Everywhere the break statement will be mandatory. And now that although I can write it anywhere, but the evaluation of the default will be at the end. If there is no matching case is found, then only the default case will be executed. Okay. So again, do not be confused if default statement is written somewhere, maybe whether I can write it in between or not, or I can write it at the top or not. It's all valid. Default can be written anywhere, but compiler is going to evaluate it only after comparing only after evaluating all the cases. So all that is completely valid. Okay, hopefully this has cleared your doubts about the switch. So now I'll move ahead and now let's talk about the concept of looping in Java. Okay, so I'll just remove it. I'll check whether I have added it into the repository or not. So demo switch I have already added, so not much is required. So let's talk about the loops and a few of the hands-on exercises I'll give you where your looping and switch cases, arrays will be improved. Okay, so now I'll see the first type of loop. Java actually provides you, or any programming provides you, two type of loops. What is that? That is fixed loops and variable loops. Now what is fixed loop? What is a variable loop? A fixed loop is one where the programmer knows the number of iteration. Programmer knows the number of iterations. Whereas in a variable loop, the programmer does not know the number of iterations. That means the number of loops will not be known. Does not know the number of iteration. So whenever we know the number of iterations, then we can go for the for loop, and if we don't know the number of iterations, then we can go for the while loop or do while loop. Okay, this way we can use any of the loop. So if I know the number of iteration, I'll always go for a for loop. So let me just first look at the syntax of the for loop. How do we make use of a for loop, and what exactly for loop looks like, and what are the compulsion in for loop, what is not. So a for loop basically will be generally will be used when we know the number of iterations and takes 3 arguments. None of the argument is mandatory. So if I just write a for loop like this and just say looping, this is all fine. It's completely valid. Even if you see such type of syntax in your OCJP exam, the answer will be what? You will not get any compile time error. This loop will get into an infinite loop because there is no condition given. So let me run this and show you that. So you can see that it is getting into an infinite loop. So I'll terminate this and clean up everything, right? So let's go here. So 3 arguments is what our for takes, but none of the argument is mandatory there. Okay, I can also have an int I equals to 0 and then I plus plus I can give, and I'm not giving any condition. So because I'm not giving any condition, so my loop again will go into an infinite loop and it keeps incrementing I, right? So let's save it. And what happens if the value of I reaches to the last value in an integer? Because I is an integer, it cannot hold that, right? So again the bits will be shifted and it will come back to that. So I is plus plus, so it's printing I is not incremented, I is getting incremented by 1 in all the loop, and I plus plus should happen, so I is becoming 1 all the time. So it has entered into an infinite loop, looping plus 1. So I did not give it as I, that's why it is not incrementing the value. So let's give it as I so that it increments the value. Now run it. So you can see that it increments till the last range of int. After that again it will change. So let me stop it. You can see it in your machines. So you can now also see that there are 2 arguments which I have given as discussed in the previous example. None is mandatory. So I'll just write that syntax, the valid syntax. So this is a valid syntax of a for loop. Okay, valid syntax. Now coming here, if I say something like I is less than 10, so at that time what happens is first value, this first part of the for loop executes only once. Then it comes and checks what is the value of I less than 10 or not. If yes, it executes the loop body. After executing the loop body, it either increments the value or decrements the value. Okay, so let's save it now. So some people are confused that this is the third part that is executed into a for loop. No, this is not the third part. The third part is the body that will be executed. So here itself we can test that if this is the third part, then it should start from 1, not 0, right? I plus plus should happen. So irrespective whether you write I plus plus or plus plus I, at that time it is still the same. So let's save it and run this and check. So you can see that the looping has begun with 0. That means body is executed first and then the increment and decrement is happening. So this way we can write a very simple for loop. So let me put this into the repository. I have given the syntax for both of this, for loop without any argument and the for loop with the argument. So demo 3 for loop. Okay, this syntax is valid and they might ask you the same question in OCJP. Now what happens to a for loop if the initial condition itself is false, that is I is 11 and I is less than 10? What happens in this case? So in this case obviously the condition is false, so it does not enter into a loop body at all. Fine, so that's how it works. Looks good. Now you might be thinking, what is this plus plus and the plus plus before pre-increment and post-increment? So I'll just remove this for from here and show you the example of pre and post-increment. After that we'll come back to the for loop and design a well-formed for loop. So see, if suppose I write something like int I equals to 10 and then I write int j equals to I plus or let's say phi plus I plus plus. So in this case what am I actually trying to do is I'm trying to say phi plus I plus plus. Okay, I plus plus always means what? I plus plus always means I plus 1. That's it. Whether you write I plus plus or you write plus plus I, both are what? Same. I plus 1. Both are same only. Let's see that first. So I write system.out.println I plus plus. So when I write I plus plus, 10 will become 11. Oh, sorry. System.out.println is again what is being used here. So what I'll do is I'll simply say I plus plus and then I'll print the value of I. So I plus plus or plus plus I is always what? Plus 1. So I'm printing it, it is 11. So when I go for plus plus I, that will also be 11 only. Okay, no difference. When it is independently used like plus plus I or I plus plus, it is the same. It will not make any difference. It will make the difference only when I'm using it with something else. That is something like this. Okay, if I'm trying to do something like this, int j equals to phi plus I plus plus. Okay, so system.out.println, now if I see the value of j, so j should be 5, that is 5 itself, plus I plus plus, which is 10 plus 1, 11, right? So 11 plus 5 is 16, right? So there is a possibility that it can be 16 or it can be 15 itself. How is that? So we have to understand whether it is 5 plus I, that is 10, plus 1. What is it? Or first this is happening, only this 5 plus 10 is happening, or 10 plus 1 is happening. That is what we need to see. This is post increment, right? So if I see the value of I will obviously be what? In this case I is going to be 11 because I plus plus is written. So when I plus plus is written, it is 11 for sure. But if I write a j here, now this is 11, but 5 plus 11 is not happening there. 5 plus 10 is happening. So let's run this and see that. So you can see that 5 plus 10 is happening. That's why it is 15. It is not 16. Same line of code. If I write, instead of writing this, if I write it as a pre-increment, so now the value will be different. It is going to be 16. I will still be 11. The result is 16. So in this case, what is happening is 5 plus 10 happens first. Okay. J will be 5 plus 10. J will be equal to 5 plus 10. And then after that second line, what happens is I is equal to I equals to I plus 1 happens here in the above line. And in the below one, what happens is first I equals to I plus 1 happens. I equals to I plus 1, which is what? 10 plus 1, 11. Then the other expression j is equal to 5 plus 11 happens. That's why it is 16 and this one is 15. Okay, I hope that you have got to know. If written individually, it's just plus 1. If it is combined with something else, then based on pre or post increment, the value is changed. So let me copy this and put this into the repository as pre and post increment. So hopefully this is my demo for pre and post increment. Let's put this. All right. So now I'll just test your understanding. What you do is you predict the result of this system.out.println. Let's say I equals to 10 and I write I plus 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 10. So I'm writing a post increment here, system.out.println int I equals to 10 and I plus 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 10 is what I'm writing. So here is a post increment value, system.out.println I'm doing. So you predict the result of this, whether it is going to be 20 or 21. What do you feel? So I hope you have already analyzed the result. Now let's check what is the output of this. So it is 20 because of the post increment which I am using here. If in the same line of code, if I use a pre-increment, so it will become what, I plus 1 first, that is 11 plus 10. Now it will be 21. Okay. Now one more tricky question to you. Let's see whether the concept is clear to you or not. I will now make it as I. So let's see what will be your output. Just think over it and tell me what it is going to be. Up to here you already know that I is 10 post increment, so 10 plus 10 happens, so it will be 20. So then 20 plus what? 20 plus, is it 10 or 11, right? So is it going to be 30 or 31? What do you think? Hopefully you have already again decided your result. So let's check what it will be. So it should be 20 plus 11, that is 31. Why is that? That is because, see, this expression I has changed its value. So when I comes here, it has become 11. So for this expression, it will become 11 only after adding this. Okay. So I'll put this into the repository. Later you can keep changing it, keep changing the value and test the results. Hopefully you have now got to know the difference between pre and post increment. Now let's go back to the looping concept that we were discussing, and from the looping itself we came to this pre and post increment. So I was talking about the for loop. So one more example about the for loop I'll put up, that is, I want to write a Java program, write a Java code to print from A to Z. Okay, so that's what I want. I want to write a Java program to print from A to Z. So from A to Z, I know that this is a small case A to Z. Maybe I can print capital case A to Z also. So from A to Z is what I want to print. So repetition is there. I will be using a for loop because I know that there should be 26 iterations. So I'll say int I will be equals to 0 and a semicolon. I equals to 0, I is less than 26 is what I'll get, and then I plus plus. So first let's see what will be the value of I, sorry, not int, it should be I is less than 26, system.out.println. Let's print the value of I, let's save it and run this. So this will give me the value of I that is starting from 0 to 25. So you can see that 0 to 25, that is 26 iterations. So I have the value of I, that is 0 to 25 is what it is printing. So what it is printing, 0, 1, 2, so on, right? So what I will do now is, but I don't want 0, 1, 2, 3, 4, right? So what I want is, I will say 0 plus 65, 0 plus 1 plus 65, 2 plus 65. So what will be the result for this? This will be 65, this will be 66, right? And this will be 67. And if I convert the 65, 66, 67 into char, it will be ABCD, right? So what I'm going to do now is, I'll write this I plus 65 and I will typecast this. I will convert this entire expression into a char. So I'll say convert it into char. typecasting is what I'm doing. I'll save it and run this piece of code, and you will see that I'm able to print from A to Z, as simple as this, right? Similarly, what I can also do is same thing. Instead of using a 65, what I can do is, I know that implicit typecasting happens here when I'm performing an integer operation, that is plus. So this A, capital A, can easily be converted into 65, and then the same thing happens. So this line will also be giving me the same result itself. You can see that it gives me the same result. Similarly, if I want to print the small case ABCD, instead of writing a capital case A, I can write a small case a, and I can still get the result. So these are the scenario situations where I can make use of this looping. Wherever I want to do a repeated work, I'll be using this. Hopefully the concept of for loop is clear to you. Okay, this is my demo 6. Loop A to Z is what I'll give here. I don't want to increase the length of this video more, so we will stop it here, and then in the next video we will talk about the other type of loops. We'll also see the break and continue statements. Okay, so what you can do is, because this is very basic, very fundamental, so you can keep the videos into 2x speed, and then you can practice along the code and watch the videos. So see you in the next video. If you like the videos, if you like the videos, do share it with your friends. Comment in the comment section so that I know that people are watching these videos, and see you in the next video.